Hello and welcome to the Tech Lunch podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listener's ears to new and exciting technologies they may have not been privy to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
Hey guys, I'm John.
And this week we're going to continue on with the, 3D printing world, I guess you could say, and, what it's used for, and kind of, we're going to be looking at the uses, I guess. We'll take a look at those. And also, what type of software do we have to use to get to that point?
Yeah.
So, when we're talking about, uses and software and stuff like that, John, what are you kind of thinking about when we bring that up?
Yeah, software, it's, there's many different types of open source software that realistically, even if you don't have a 3D printer yet, you can work with, you can tinker with, you can create files, and honestly, you could probably make a bit of income off of that just doing the free software side of that, posting it on certain websites. And Thingiverse doesn't sell things, but there's sites that sell them. But when I'm thinking that, it's like, okay, I got my printer, what now? What am I going to do? How do I make the model? What's going on, or where does that get directed to? And if it's G code that I'm writing, how do I get that G code? How do I compile that code? So most popular, Cura. That one's actually one of the most widely used ones. We've got my preferred one actually is Prusa Slicer, and it's just a matter of preference because realistically a lot of these do the same thing. There's small different changes and settings with like pathing and stuff like that you can get into, but that's highly technical in those things, and a lot of those places it's you'll see minute differences, and it's really like a one-off, a small thing it's kind of contributing to. Ironing is one of the examples that irons out the final layer so that looks more glossy, and that's something that actually I do on Prusa on certain prints. So if you want that nice finish, you don't want it to look like or rocky or like gritty. And then a few others like to model. Actually, one of the bigger ones, depending on if you're using it for your business or personally, Fusion 360 is free if you're using it personally as a hobby, as a hobbyist. But Tinkercad's one of those. Realistically, you could even in slicers, you can change that code, that model, that STL object file, OBJ, whatever you want to do. You can slice pieces off of that, so you can, like if you're struggling with the size of your bed, do separations of those. And then you could break it down into the actual path that your nozzle's taking. And it's funny because we've talked about efficiency before, and that's something that in these programs, that's one thing that I don't see enough of is they talk about their own efficiency. So you'll see the numbers pop up like this is how long this will take, this is how long that'll take, this is the retraction, de-retraction, blah, blah, blah. But at the end of the day, I see inefficiencies when paths cross. I see inefficiencies when supports are not bridging correctly and kind of falling down a little bit. So a lot of these things, and Ed, you can probably take this part to it, or think about this side of things, is there's not enough sensors in that side to recognize those things, to test those things. But in those programs, those applications, they're color coded. So I don't know if there's any programs on the OT side that's color coded with like, hey, this is slope, or this is the temperature is this color or whatever. But I like those things can be applied in those senses. So in the applications field, it's very basic, but it's open source. Open source means you can build on that. You can make your own.
Yeah.
So I would say, so when we're talking slope, it's mathematics. So those mathematics are generated anyway from the movements we make with the step promoters. That's data that's already on a board. So what I would say is you leverage that data. Here we go with MQTT again.
Yeah.
We leverage that data via MQTT inside of the 3D printer, and we use something like Kibana or Elastic, and we build some type of framework around that. And then we take that data and understand the data. And then from that, if we wanted to, we can make that a responsive system, which is AKA closed loop system. Mm-hmm. And then in real time, it says, hey, your slope is off from what we said that the file was. You know, I would even say I like that there are some free options there, but I would also like to see some type of CAD or CAM software package that had all these capabilities where I could do some simulation first and then create that STL file. I would like to see that environment where we could test out what our assumptions are. What do you think, Nick?
You know, it's like, you know, for me, it's like, especially when you start getting to the CAD CAM side of the house, you know, getting into like your Fusion 360s and your Autodesks and stuff like that, you know, doing your flow rates, you know, stuff that we talk about airflow rates and stuff like that. If you're trying to design a nozzle or something like that. Yeah. If you could take that and do a quick nozzle test and stuff like that, if you're building something for like a model rocket or, you know, one of the CO2 rockets that people build out of water bottles and launch them in their backyard. You know, you can build the nozzles for that so you can test, you know, how the different nozzle designs actually work for, you know, your jettisons and your jets and stuff like that. You know, being able to test that in the CAD CAM software and then be able to develop it, you know, using, you know, STLs and slicers and stuff like that, you know, it would be great. You know, if I can see, you know, what the flow is going to be, you know, especially when you start dealing with things that are, you know, when you start dealing in the world of mock diamond, you know, you're trying to see, you know, how concentric can I get my mock diamond based off of speed and power, you know, based off of thrust coming out the end of a motor, you know, that type of stuff you want to visualize, you know, and most things you can't do that with unless you have a way of doing, you know, like a fluid dynamics on it or something like that, or doing something with a little bit of speed behind it. You know, but the thing is, it also goes back to an IT standpoint, you know, where a lot of these software packages that we have are very, you know, hardware resilient, you know, and hardware dependent, a bit based on if it's a Windows operating system or, you know, a Mac operating system. You're not going to see a lot for Linux unless you talk about the open source world, you know, but it's also, you know, how much RAM I need, how much, you know, CPU power do I need, how much GPU power do I need if we're getting into that realm. You start dealing with like CAD and CAM software, you start worrying about GPU specs. You know, you start having to custom build solutions and hardware packages just to be able to support that software, which is good and all. However, this is where I'm going to play the devil's advocate, is there's companies out there that need to get, you know, off their tail that are building these gaming rigs, you know, for what? You know, you have a gaming rig, cool. You know, go play Fortnite, whatever. Mm-hmm. You know, but why don't you build a PC with that same amount of power as a gaming PC for something productive? Yeah. You know, for CAD CAM machine to do 3D printing. You know, or build one of those machines and sell it with a 3D printer. Make it a package.
I mean,
workstation.
We should go to John, but I want to jump in just a second so I can give John something to think about. Here's the thing. If we want machines to ever get to the point where they learn, and I say genuinely learn, then what we have to do is we have to incorporate these systems inside of the thing we're trying to make smart.
Right. So what you're saying is have the 3D printer do all the CAD and CAM design for you, and then spit it out on the end.
No. I still want the creativity from the person. I still want the input.
Right. No. But what I mean is, and you know, this is just to, you know, spin it up a little bit. Is I'm going to take a workstation, but I'm going to combine it with a 3D printer. So it means as I design it, I can hit the go button immediately without having to transfer from one device to another based on network design.
Yeah. That's not a problem, because when I say what I'm saying, okay, so if I want to use a mini computer, that mini computer could be leveraged against the cloud environment.
Yeah.
So my concept of, hey, I want intelligence. Well, intelligence should be a resource, and then I pay for the amount of resources I use. So, and this is just to throw it back to John. So, John, or I like to call you Champ, but his name is John, but I like to call him Champ. Here's the thing. What I would like to see from 3D printing, I would like to see somebody take a phone. I don't care what platform, Android. I don't care if it's Google. I don't even care if it's Apple. I can take a snap. That snap can be sent as a image. And it understands, take this data, convert this data to what you understand, and create this file for me. That's what I want to see.
Yeah, I can agree with that.
Yeah, I think that's something that we're getting to, and in some cases already have, maybe not to the highest quality. I think a big aspect of it that everyone needs to consider is a single picture is not going to show you as much depth, and I think that although not impossible, you can still show depth in a picture. I mean, artists do it all the time, but it's a little bit harder for that computer, if it's a mini PC or a mini environment, to not to be able to do that. But there are things that, and I'd be interested too, that you'd attach onto your phone. You plug right in, takes a little bit of the power from the phone, and then you can do maybe a 360 degree scan, some type of panoramic if you need to. Maybe even it says, "Hey, I need 5 pictures. Give me 4 sides and then top down."
Let me ask you this,
and then I'll do that.
Let me ask you this. Right now, your phone is doing that. I can do a panoramic view. I can even do a 3D view.
Yeah.
It does that with software.
Yeah.
I take a flat image. Really, not even necessarily 2D. It's more 1D than it is 2D. And that software is converting that image into that.
Yeah.
Why can't I do the same thing with the phone?
How the new iPhone 13 can do it.
I was gonna say, that's the next point. LiDAR is beautiful. It's something that's like, I don't know, is revolutionary as coming up with sonar. You know, it's like, are you telling me I could find my environment with sending this sound wave? Cool. You're telling me that I could see in a low light environment by sending a single light ray?
Yeah.
Cool. That right there. That to me is what needs to be kind of leveraged into that camera system, so that like it is able to be more efficient. Because I don't think that it's impossible to do that scanning, because yes, it does exist. I just don't think it's very efficient right now, or at least I haven't seen it efficiently make a model. It's more of the like the minimalist. Like, you definitely see the polygons. You see, you don't see, it doesn't create a clean mesh on it, and some of those little small deviations are not as pronounced. And honestly, it is depending on the size you print it in. And in most places, most hobbyists are only printing on like a 200 millimeter by 200 millimeter square plate. They're not doing anything.
Yeah.
huge.
So, and the thing is, if you think about it, LiDAR came, out of the military realm.
Right.
You're dealing with LiDAR. You're dealing with, coming from the law enforcement world and stuff like that, for like, registering speed. That's what it's there for. You got LiDAR, radar, and then you start getting into like, MVG and sonar and stuff like that, depending on, what makes up your environment based off of shadow.
Yeah.
So you're having to, play with that realm. So, LiDAR is one thing, being able to use, like a mesh sonar would be something else, and, just to be able to triangulate the location of the corners and stuff like that is another thing, however, that's, here nor there.
Well, here's the thing. This is where I'm going to challenge both of you, because I disagree a little bit, just a little bit. I disagree that I still believe with just an iPhone, maybe I can't take one picture. I can take 4 pictures.
Yeah, I believe it. I believe we should be able to mesh them together, yeah.
5 pictures, and then I got a slicer.
Right.
The slicer should be both a combiner and a slicer.
Yeah.
I can compile an image into G-code and slice that image into G-code coordinates.
Yeah.
Why is that not possible? It's a little bit of coding. Maybe it's a lot of coding. Maybe that coding doesn't exist. But I can use TinyML, which is a free, open source machine learning application, and incorporate that in with a phone.
Yeah. I just think right now it's the fact that, the GPU and stuff like that, that's not there on the cell phone right now. I think once we figure out how to better the chips and cell phones, I think once we see, I'm not an Apple bandwagon by any stretch of the imagination. I'll tell you that right now. However, it's once they can move their M1 chip that they have in their computers and the new, MacBook Air and also the iPad Air now. Once you move that M1 chip into a cell phone, all games are off at that point. The boxing game begins because you're in the realm of computer stuff. You're away from silicon chips. Now you're more to the M1 mega processors that have your GPU built in, your RAM built in, and stuff like that, all in one package. Once we see that, I think that's a possibility.
So, I challenge you again. What is a hologram?
I love that you actually brought holograms up, because holograms can be there's a whole bunch of different ways to think about it.
A static hologram, not a laser. A static
so you're
hologram.
talking about I don't have you're not saying I have a prism, and depending on where I shine it.
So basically, I have a card that's a hologram, and if I turn it in a certain way, the light refracts on it and do whatever.
Right.
Yeah. It's something static, right? Mm-hmm. It's static images that are leveraged with some physics,
right,
and with light, the physics of light, and it gives us a perception.
Yeah, and
if I can do that with a baseball card, why can I not do the same thing with 3D printing?
Think about it. NASA just sent a doctor and some of his people to the International Space Station, and they were still sitting on their practice down in Florida via hologram. They called it holographic medicine. They brought them right up to the International Space Station.
That's incredible.
Why can't it be done?
See, I don't know. Okay, you touch on that. Holograms are something that kind of have a special place in my heart because it's like you've talked about it all the time. Being a nerd, I've kind of been fixated on a lightsaber. It's like, okay, so how do you create this saber of light? It terminates at a certain point, and it maintains that temperature. Mm-hmm. We don't. Of course, there's not anything like that right now that I know of.
Not this wireless.
It's not as wireless like that. But you think about it, it's the creation of
add wires to it. Image. There you go.
Yeah, right. It's the creation of that 3D image, and that 3D image, people are saying it's like these 4D places and these 5D like theaters, blah blah blah. But that's incredible. You see that some of the sporting games, like those lights going around, that's incredible. So that's kind of, you just touched on something that's like an ultimate fascination of mine. Is like, how do you get that light to terminate at those certain places? Are they hitting other light rays and stopping? Like, there's a whole bunch of like questions that are raised on the physics side and on just like it's visually stunning most of the time. But then there's a book that I was reading throughout college. It's called Holographic Universe, and it's thinking we even get, and I know this is kind of getting off track a bit, but it's like it's every bit of your thought process can be viewed from a different angle, because you think about a hologram is showing a different designs from different angles. So it's a perspective thing. So you take it even we could break it down into 3D printing. You take it from a different perspective, and hey, I'm not thinking about what is this thing producing. I'm thinking about what process is this improving? Whose life is this improving? And then that kind of stimulates your thought process. And that's kind of like, literally, you guys got a picture in the side of my thought process. Is like, okay, we're thinking about it one way. We need to spin this turntable and see what other angles we can see from this.
Yeah, well, it's like, if you really want to tie it to 3D, into 3D printing, is, why can't I take a piece of software that can configure and project the hologram that makes sure if that's actually useful or not before I pull the trigger and actually print the darn thing and waste the waste the filament. It's I guess you could call it a pre-proof of concept
or machine learning.
The thing is then it's like, okay, so now we go into a physical CAD CAM at that point.
So here's another challenge.
Or a digital CAD CAM, if you think about it.
What is an MRI? What does an MRI do? What does an MRI do?
It's using microwaves for a full body scan, right?
Yeah.
But it's for in particular, it's the brain.
Yeah.
Okay.
In particular, it's mapping the brain.
Yeah.
We already have a 3-dimensional map of the brain from our crude way of methods of cutting out the brain and touching it and feeling it and measuring it.
Yeah.
To where we took a measurement system where we would measure it and say, hey, to where we went to, hey, let's kind of make this in software, to where we say, hey, we got an MRI system that's mapping it. So here's the challenge. What does every 3D printer machine do that is of any quality before it starts a print? There's a calibration that it does.
Yeah.
Touch this corner, touch that corner, blah, blah, blah.
Yeah, bed level.
Why could I not put something on there and say, hey, I put an apple on there. Do your corners, map yourself. I want you to scan with a camera, 360 degrees with that same servo system or stepper motor system I have with the camera from 3 angles.
Yeah.
And have it recreate that image?
And then take that data right from the camera and put it as a STL file into the 3D printer.
Yeah, so it'd pretty much be a 3D printer
3D printer scanner.
mounted 3D scanner
3D scanner right there.
based on the machine.
Yeah, I like that. See, I like that idea because when you first started talking about holograms, and I think about in one of those. Oh, I got you. And one of those ideas that I'm kind of going for is oh man, you're gonna have to stop me because I lost my train of thought.
No, keep going, man. Keep going. It's okay.
Keep rolling.
So we talk about holograms. We talk about no, here it is. So I'm thinking of because we talked about applications. Got the train of thought kind of derailed for a second there. So we talk about the applications and using those things to create G coders, right? And then we talk about we want it to automatically measure or scan its environments and possibly create that G code. Those two things are intertwined because in certain softwares you can have your sketch, your canvas in the background, and it's putting that there. So there's nothing to me in my mind that would limit you from being able to take that object and say, hey, boom, this object is here. I need you to try to fill these dimensions, or at least tell me the dimensions before you try to fill in the apple that's already there, and then go from there. Because, like, how many times do you have a piece that you glued together, and you're like, man, this integrity is, like, shot. Like, I can't, this connector, this gasket, this whatever tubing is going to shatter, but I need it. So you set that in there, glued piece together, try to sand it down, make it as clean as you can, have it measure that, and then you pick your infill. So I mean, it's incredible. I think that's possible. I mean, we might have our $1 million idea right there.
Yeah, maybe, but would you give it away?
Yeah, right. No.
We don't give anything away. We're open source, and the reason we're open source is because if we give it to the community will build it, and for us, the building is the process.
All right. Hey, if you do build it, we do take donations.
Yeah.
Hate to say it,
Not gonna
we're just a bunch of IT and OT guys that, but with that, it's just it's always interesting when you start thinking about the software and stuff like that goes behind, 3D printing and kind of what it is, and where it's going in the future. As we kind of walk the path of 3D printing, we kind of remember that, remember what's ahead of us and what's behind us, all in the same process. We're down to our last couple minutes here, but I'm gonna say from my side before I turn it over to Ed for the final thoughts is, thank you, thank you everybody who's kind of dialed in this thing, no matter where you are in the world. I was looking at the statistics the other day. We got people from all over the world listening to us, and we 100% appreciate that. We got some stuff coming out on the YouTube channel. That's always down in the link description. We got some other people coming on board soon. And we're here for you. If you need anything from us, you let us know. We'll be more than happy to get you the information you need. So, I'm going to turn over to Ed for, I guess the charge of the week and, kind of lead us out. All right, Ed, you take it.
So I can remember when I was a kid, the first time I saw a Polaroid picture. Something from nothing, instantly put out. Mm-hmm. That was, to me, the inception of 3D printing. What we have today is a Polaroid picture. what we should strive to get to is I should be able to use voice recognition and say, build me a heart.
Right.
And it builds it. Whether we leverage that over Google or we leverage that over whatever platform to go take this model, or I build a database. So for me, I think that these are things we should do as a community. We should think about how we can make these things better. Excuse me. And as always, we appreciate everybody that has supported us. And we also challenge you guys to challenge us. If you want some different concepts or something challenging, let us know. And as Nick said, next month, the $300 3D printer challenge is on. It's the beginning. And thank you for tuning in.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.